Now, let's try to allow players to adjust the direction and angle of the shot. Think about it, when we shoot, do we adjust the shooting direction by rotating left and right? Adjust the shooting angle by pitching. The size of the shooting force and the pitch angle of the shot determine the shape of the parabola. To facilitate user operation, we need to make a UI.
First, import the image material. Then, open the joystick UI. Drag the basketball icon and the material just imported to the UI editor window. In the hierarchy window, change the node name to throw, indicating the shooting button. Set Tinker proper to follow right corner. Set its width and height to Beth Samis left joystick. Set its Xandy value as frontalo right corner -150. Change the transparency in its color proper to 50. Drag the left arrow image to the throw node as its child node. Change the node name to left. Set the W value to 40 and the H value to 100. Set the anchor property to the middle of the left. Set its X value to -40. Change the transparency in its color property to 50. Copy the left node and change the name of the copy node to right. Change the anchor property to the middle of the right. Change the X value to 40. Replace the texture property of the right pointing arrow image. Copy the right node to Jetip node. Change its 1 value as to 100 and 40 respectively. Change Finker proper to top center. Change its value to -40. Replace the texture proper to off to Pordaro image. Copy the up node to get the down node. Change the anchor property to bottom center. Change its Y value to 40. Replace the texture property of the downward arrow image. In this way, our shooting and direction control UI is ready. Press the shortcut key Ctrl+S to save. Go back to the game window to view the effect. Next, we will change the previous full-screen touch shooting design to press the shooting button to charge the shot. Create a new TypeScript script in the scripts folder, and name it Throw Controller for shooting control. Mount Throw Controller to the original joystick node. Then, find the previous shooting logic, that is, the relevant code in the progress control script. Save the variable of whether it is in the charging state to game data. Then, replace this .isCharging with game.data.isCharging in the progress control script. Add a charging progress variable in game data to facilitate the acquisition of this value during subsequent shooting. Make corresponding modifications in the progress control script, and use the value of the progress bar saved in game data when the event is released. Record the value of the progress bar in real time in the update method. Then, you can copy the relevant code involving the mask and comment it out. Paste it into the onStart method of throw controller. Solve the relevant errors. Remember to get the shooting button at this time, so make corresponding modifications. Then copy and paste the reference-related methods from the progress control script, and comment out the corresponding code in the progress control script. Transform the error code using event subscription and publishing. Add event subscription and unsubscription related codes in the progress control script. Save and test. The shooting button is normal. Next, we need to implement the left and right buttons to control the shooting angle. When shooting, everyone looks directly at the basket, that is, the basket is in the center of the field of vision. In order to make the user experience more realistic, we need to implement the left and right buttons to control the camera to rotate around the basketball. First, we need to get the corresponding buttons in the shooting control script. Add relevant code in the onStart method to get the up, down, left, and right buttons. First, implement the left button to control the camera rotation. When the left button is pressed, the camera starts to rotate to the left and rear around the basketball, and the camera rotates to the right and front around its own y-axis synchronously. When the left button is released, the rotation stops. We found that left and right rotation is nothing more than inconsistent rotation direction. So we can implement it like this. Then publish the event in the corresponding processing method. In the onStart method of the camera control script, subscribe to the left and right rotation camera and stop left and right rotation camera events. In the onDestroy method, add the corresponding unsubscribe code. For most students, the next difficult part comes. To make it easier for everyone to understand, I drew a few schematic diagrams for you in advance. What we expect is that when the left arrow button is pressed, the camera rotates from point A to point B around the QO vector, where the basketball is located. We have listed the APIs that need to be used in this process. Students who want to learn more can query the API after class. At SamTime, samplocodizel sogavan here. Thathard 9 samplocodamians rotating kavectrant the spigiri around the xisbiach rotain angle. Here rotation speed represent the angle of rotation. After understanding these, let's complete the relevant rotation logic according to this schematic diagram. First, add the left and right rotation speed configuration and variables. Add a switch to see if the camera rotates left and right, and set its initial value to true, indicating no rotation. Then improve the two event subscription methods. When the rotation starts, set the variable to stop left and right rotation to false. When the rotation stops, set the variable to stop left and right rotation to true. In the left and right rotation event processing method, set the rotation speed according to the left and right directions. Finally, in the onLatUpdate method, perform left and right rotation processing according to whether it rotates left or right. Save and run. Test. It is found that the camera rotates around the basketball behind the basketball basically normally. However, the camera's shooting angle should also be adjusted synchronously when the camera position rotates. Here we use the RotateLurks method of the transform object. The last parameter of this method indicates whether the rotation is relative to the local coordinates or the world coordinates. The default is true, which means relative to the local coordinates. We only need to rotate it around the y-axis. Therefore, adding a line of code can adjust the camera's shooting angle. Save. Run. Test. It is found that the camera rotates left and right normally. For the same reason, it is not difficult to adjust the camera's pitch angle. The first step is to copy the relevant logic of the left and right buttons in the onStart method of the shooting control script. Make modifications. Copy the relevant processing logic and modify it. second step is to add relevant logic to the camera control script. Copy the relevant parameter settings for left and right rotation, and change them to up and down rotation settings. Then add the required event subscription and unsubscription codes in the onStart method and onDestroy method respectively. Copy the processing logic for left and right rotation, and change it to the logic for camera up and down rotation. Finally, in the onLatoupDate method, copy the previous logic for camera left and right rotation. Change it to the logic for camera up and down rotation. Note that when the camera's top-down angle is adjusted, it rotates around the x-axis. Save and run. Test. It is found that the camera shooting angle is adjusted up and down, and left and right. However, when shooting, the basketball does not fly directly in front of the camera's field of view. In addition, after shooting, it is best for the basketball to return to the shooting position at the beginning, so that the player can find the shooting feeling in the same position.